Hello students, today we are going to learn about uncertainty and measurements. So uncertainty and measurements. So first we will take the video which is related to addition of uncertainty. Then we will take subtraction. Then subsequently we will take the multiplication and division. Okay, so let's start our video. So here they have given two values. First is 6.0 plus or minus 0.7 and second is 8.6 plus or minus 0.6. So 0.7 is absolute uncertainty and 0.6 is absolute certainty of second one. So now this absolute uncertainty is also called as tolerance value. So let's start and do the addition of this. We will name this as length 1. 6.0 as length 1 plus or minus, and this tolerance value of 0.7 is delta L1. Okay, and here length 2, this 8.6 as length 2. Okay, here I will separate it, plus or minus, then delta L2, 0.6 as delta L2. Now for this one formula is there. The formula is like this. You have to add this length and this length first. Okay, so this formula becomes L1 plus L2, then this tolerance value whatever is given plus or minus, then in the bracket you have to put delta L1, this is tolerance value or absolute uncertainty, and delta L2, this L2, delta L2, bracket closed. Okay, bracket closed here. So in this way we will substitute the values as given here. So first length 1 is 6.0 plus 8.6, length 2 is 8.6, so 8.6, then plus or minus, I will write here plus or minus, space delta L1 is 0.7 plus delta L2 is 0.6, bracket closed. Now 6.0 plus 8.6, this we have to add. We will get, after adding this, as 14.7, 6.0 plus, so 14.7, and now this absolute uncertainty, which is in squared bracket, or it is called as tolerance value. So 0.6 plus 0.7, this we will add, and we will get it as 1.3 here, 1.3. Now we got this answer as 14.7 plus or minus 1.3. Now if we want to find percentage uncertainty, that we will do on the next page. So here we will write 14.7 plus or minus 1.3. So for this one formula is there. Percentage uncertainty is given by this, whatever that absolute uncertainty of total you got it. Okay, total length absolute, then upon measured length what was there, so into 100. Means simply we can say this divided by this into 100. So we can write here 1.3 divided by 14.7 into 100 will give certain value, and that will come to 8.84 something it will come, but significant figure is only here 2 digits. So significant figure is here 1 digit only, as you can see here 1 digit, here 1 digit, here also 1 digit after this, and here also 1 digit. So you have to write in this way. The answer, it is coming 8.84, but you have to write it as 8.8, which is equivalent to approximately 9. So 9% uncertainty is 9 for this. Okay, so now we will take another example for addition of uncertainties. Okay, so here they have given two values. First value is 11.0 plus or minus 0.7. This is second example we are taking, and then another value is 16.6 plus or minus 0.5. So now here we will consider this as A plus or minus this tolerance value of 0.7 as delta A, and this we will consider this as 16.6 as B plus or minus, we will write delta B. Okay, I will separate this. So now we will solve this question. Okay, so here we can solve here. Okay, so for solving this question we have to actually take, so we will add this. So the formula will be like this: A plus B then plus or minus in a squared bracket we will write delta A plus delta B or tolerance or absolute uncertainty in the bracket, square bracket. So now we will write all the values here. 11.0 plus 16.6, substitute the values like this, then plus or minus this, plus or minus this one, then delta A is 0.7, so square bracket 0.7 plus 0.5. so now we will solve this. So 11.0 plus 16.6 will come around, say, 27.6. So 27.6, then plus or minus 0.7 and 0.5 will come 1.2. So this is the value what we call now percentage uncertainty. Percentage uncertainty means this value upon this value into 100. So that will be equal to 1.2 divided by 27.6 into 100. So let's solve this and you will get 4.58, but one significant figure is there, so instead of 4.58 we will write 4.6 only. 4.6%, which is equivalent to 5%. So that's in this way you have to write, which is equivalent to 5%. Okay, so in this way you have to do the uncertainty. Now we will take subtraction of the uncertainty. Now for subtraction of uncertainties, you can see though you have to subtract the numbers, whatever the measured values are there, but you have to add the uncertainties or the tolerance value which is given after plus or minus, that you have to add, okay, in subtraction also. So we will take few examples of subtraction. We will write a formula for this. Okay, we will write one formula. Suppose A plus or minus delta B they have given, and another example they have given delta AB plus or minus delta B. So now you have to subtract these two values. So what you have to do now, this minus this first. So A minus B, okay, A minus B, I will erase and write again. So A minus B, then plus or minus, and now this one is there, this delta B. Oh, sorry, this is delta A. We have to consider this as delta. So we will write here as delta A. Okay. So delta A. So this delta A in a squared bracket we will take, plus this value delta B. Now this value is there, delta B plus delta B. Okay. So we can solve this using this equation. Okay. So now let's take one example. Suppose they have given two heights and you want to subtract it. So let's see how we can do. So let's take one example. So first value they have given as this, suppose 66. This one is there. So here they have given this as okay. So let's take this example. So they have given one example here. It is height 2. First is height 1. Height 2 is 76 and height 1 is 79. Okay, so we will write here, suppose A plus delta A. This they have given as 79.50 plus or minus 0.06, and this value, this delta B, second they have given as 76.30 plus or minus 0.07. So now what we have to do now, for this we will substitute the values. This delta A and this A is equals to this 1 and this is 1 and this is 2 and this is 2. So here this value is there, so A, this is A, means A, and this is delta A. So here we will substitute, and this is B, 76.3 is B, and this is delta B. So now we will substitute the values and get the answer. Okay, so let's do. So delta A they have given A minus B. So in this equation we will substitute the values and we will find the answer. So let's do. So A minus B. So we have 79.50 minus 76.30. B is 76.30. 76.30. Then plus or minus, this plus or minus, we will write plus or minus. Then bracket, this square bracket. So we will write 0.06, delta is 0.06, this value 0.06. So 0.06. Then delta B is 0.07. So this is that. So plus 0.07. Bracket is closed. Now let's solve this and we will get the answer. So 79.50 minus 76.3 will give 3.2. Then plus or minus 0.06 plus 0.07 will give 0.13. So now we will find percentage uncertainty of this. Percentage uncertainty. So means 0.3 divided by 3.2 into 100. So 0.13 divided by 3.2 into 100. So we will get this as 4.06. But the thing is that one significant figure is only needed here. Two significant figures are needed here. So in this case, we will write 3 significant figures are needed here. So we will write the answer in the 3 significant figures, that is 4.06. So 4.06, which is equivalent to 4.1 or 4. So we can write like this, equivalent to 4%. So in this way you can do the subtraction of uncertainties. So we will get 4.06 or we can write 4.1% or 4%. So in this way you can do subtraction of the uncertainties. Now we will do few more questions related to subtraction of uncertainties. Then subsequently we will do division and multiplication later on, and we will take few examples related to this. Now we will take another example. In that now there will be addition and subtraction combined. So suppose they have given like one question here. So they have given let's take. So here they have given P plus or minus delta P equals to 5.0 plus or minus 0.2. Then they have given Q plus or minus delta Q value as 6.0 plus or minus 0.3, and they have given another value of 7 which is C PQR. They have given R plus or minus delta R, which is equals to 7.0 plus or minus 0.4. So now they have asked you to do this, A plus B minus C. So here one subtraction is there and first two values you have to add. We can say we can write it as they have asked in this way. We have to solve this. So it is like P plus Q minus R. So this P and Q values, this you have to add, these two values, and this you have to subtract. But we know that even if subtraction is there, this all uncertainties will add up. This all uncertainties values are there, they will get add up, and these two will be added, this 5 plus 6, and this will get subtracted with this. So we will get the answer. So let's solve this question here. So as here you can see, they have given the value as 5. Here we will write the equation as it is. So let's write the equation. So here we will write here delta P plus delta, let's erase this. We will write P plus Q minus R plus or minus, then in the bracket we will write deltas, all these deltas values, delta P, this is the formula, plus delta Q minus delta R. So this is the formula. So now substitute the values in this formula. So let's 5 and 6 are for P and Q, and 7 is for R. So we will write 5.0 plus 6.0 plus minus let's, because it is minus, so let's make it minus 6.0. So minus r value is minus 7, then plus or minus, not delta values are there, so let's check the delta values. 0.2 plus 0.3 plus 0.4, all this will get added. 0.2 plus 0.3 plus 0.4, so delta p is 0.2 plus q, delta q is 0.3, then delta minus, it is not minus, it will be plus as always. So here always remember, people make mistake here, so that's why make it plus. Okay, so that's why I intentionally made here a mistake, so you can understand here that this never subtracted. Wherever minus is there, so you have to still add the uncertainties, so you have to still add it. This also will be added. I have written here minus, so that is wrong, so you have to actually add it. So plus, so plus delta r will become 0.4. so this is the correct formula. Now let's solve this equation and we will get, so here we will get okay, so 11 minus 7 will come to 4, so 4.0. okay, 4.0 plus or minus, now 0.2 plus 0.3 plus 0.4, so 3 4, this will come to 1.9. so 1.9 is 19, so now 1.9. now percentage uncertainty we will find out. Percentage uncertainty equals to 1.9 divided by 4.0 into 100, which will be equals to 47.5%. So in this way we can solve this question, all this uncertainty question of addition and subtraction. In the next video we will take about multiplication and division, and we will take few geometrical figures to solve this type of examples. Okay, now in the next video I will be coming up within this week, so let's make the videos afterwards, then I will upload it on this YouTube. Thank you for watching this